Hi everyone, this is Joe and Jordan's Practical 3 for Don Ruba's PLC class. For this practical, we were given a temperature set point control program with a potentiometer wired to our PLC module. Right here we have our input diagram for our circuit. We call that heater sensor because we are sensing a set point and then controlling it with a potentiometer. At the top we have our stop push button hooked up to advanced HMI digital input 0. Start push button is connected to advanced HMI digital input 1. Our deadband 5 is connected to advanced HMI digital input 2. Deadband 10 is hooked up to advanced HMI digital input 3. And then our manual alarm reset is hooked up to advanced HMI digital input 4. For our output diagram for a program, we have our local 3, 0, channel 1, hooked up to our analog output, channel 1, and then our local 3, 0, channel 0 is hooked up to our analog output, channel 0, for our advanced HMI digital side. And then down below we have our local data outputs going to a real output. The first one, data 0, bit 0, is going to our heater on to let us know that our heater is on. Our 1 bit is to let us know that our circuit is started up and okay to run. And then the final rung for our output is bit 7, which is a flashing bit to let us know that the temperature is too low.
Here we have the program actually running on our PLC with the advanced HMI. So our top analog output is what the current sensed temperature is, which is on this potentiometer. We're using that as a pseudo temperature sensor, so we can just simulate it. So we can move that down from 0 to 100 for our temperature range. So I'll just leave it at 65 for our initial temperature. Our track bar is set up so that it is able to move what our set point temperature is, which I will just set to 70 degrees. Our input 2 and 3 were the 10 degree deadband and 5 degree deadband, so that way we can set it. So our start cycle is set to, if I hit the start button right here, it should go green and latch. We'll see on our PLC that it says that it is heating and that it is also working. So if the program is turned on and the startup flag is okay, bit 1 will be turned on. If it's heating, bit 0 will be turned on. So we have our deadband set to 5, so when it is lower than 65 degrees, or just at about 65, it comes on because that's minus the 70 degree set point. If we hit 70, it still is on. It'll keep heating until it hits 75 degrees, and then the heater is turned off because that's the upper range of our deadband, 5 degrees on our set point temperature. So as it keeps going down, we'll see the heater turns on. And then as we go up, the heater will turn off. So we have that being fed in from our voltage power supply that's able to supply a reference voltage for this potentiometer, so that way the sensor is able to work. And then if we leave our temperature too low for 60 seconds, so as we are approaching that, we can explain here that our flasher timer is on a 1 second interval between the two of them, and when the first timer is done, it'll flash on and off that alarm bit. So right there, we hit 100, or we hit the total preset amount for the timer without the temperature actually increasing. So now our alarm bit has been latched, and over on the PLC, bit 7, which we set as the alarm output bit, is now flashing in time with that. Which that is a latched bit, which will not become unlatched unless we go ahead and hit our input 4, which is going to be our manual reset for the alarm. And as you can see, the program isn't running still even after the reset on the alarm, because you have to hit the start button again because everything got unlatched when that alarm bit at the very top of the program cut off the master control relay and our start button flag.
Thank you for watching. If you have any questions about any information presented in the video, please leave it down below and we'll be sure to answer those questions as soon as we can. And as always, thanks for watching. See you in the next one.